Here we're going to go over the tryout problems. We're going to do the JV events first. So let's start with event 2. So there's a whole bunch of theorems you have to know for this event. They are in the notes. Okay, so here's the tangent point. A, B, C, D, E, F. AF equals DE, so like X and X. BC equal 10. AB equal 9. Okay, so there's two theorems. Oh, what are we finding? BD. So why don't we call that Y then? And why don't we call that Z? Because we don't know what that is. So these are the two theorems you got to know for this problem here. So if you have a circle, a tangent, and a secant, then this squared equals this times that. So if you call this A, B, and C, A squared equals B times B plus C. And then, if you have two secants, like this, BAP, BAP, A, B, C, D, then A times A plus B is equal to C times C plus D. All of these are derived from similar triangles, but you need to know them so you can do problems quickly. So, here we have a tangent and a secant right there, so 9 squared is equal to X times X plus Z. You get 1 point for writing that, and then look right here, you have two secants. So then we use this theorem. X times X plus Z equals Y times Y plus 10. Now how are you going to solve this? Well, notice that this equals this, therefore this equals that. So 81 is equal to Y squared plus 10Y. 0 equals Y squared plus 10Y minus 81. And you can't factor that, so you got to use the quadratic formula. So Y equals negative 10 plus or minus the square root of B squared minus 4AC. You know what? I don't feel like it's too early in the morning to use the quadratic formula. I'm just going to complete the square. So here, take half of that number and square it, 25, 25. I think it's a little easier. 106, y plus 5 squared. Anyway, quadratic formula is a formula for completing the square. So y plus 5 is equal to plus or minus root 106. So y equals negative 5 plus root 106. How come it can't be minus? Because it's negative. How can y is a length? Some of you just kept the minus song. So, is that the answer? No, because some of you are not reading the problem. That's just y. It says to find BD, so the answer is actually y plus 10. So you have to add 10 to that, so the final answer should be 5 plus root 106. Please read the directions. Okay, now number 3. A lot of you who made the team, you just had no idea. But this is the kind of level of algebra that you gotta have. Equals b squared plus 2ab. Now, the algebra is quite involved. I'm just gonna do one of them, and then you're gonna do the other. I'm gonna solve for either x or y. You're gonna do the other one. You need to make the corrections. So before I do anything, I'm going to just make sure I copied the problem correctly. And I did. Okay, so can you see that you probably don't want to use the substitution technique here, because solving for y in one equation and then plug it into the other, that'll be pretty messy. So we're going to use elimination. So if I'm going to do elimination, what should I multiply the first equation by? Well, it depends what you want to eliminate. Now, if I want to eliminate y, right? Then I'm gonna need to multiply it by a so that you get ABY. And this equation, I'm gonna multiply by b so you get ABY. So when you subtract them, they cancel out. So the first equation is a squared x plus ABY equal AB squared plus 2a squared b minus a cubed all over a squared minus b squared. And then if I multiply the second equation by b, you get b squared x plus ABY equal a squared b plus b cubed all over a squared minus b squared. And then if I want to eliminate the y, you subtract. So you get a squared x minus b squared x equals, these cancel out. And then over here, when you subtract, you can make a least common denominator. So it's going to be ab squared plus 2a squared b minus a cubed minus a squared b minus b cubed. And then let's simplify. Factor out the x, and you have a squared minus b squared equals, and then what do we have here? What do we have here? I guess the only thing you can do is add this one and this one, yeah? So ab squared plus a squared b minus a cubed minus b cubed all over a squared minus b squared. And in order to simplify this, so you got 4 terms here, you got to factor by grouping, which was an event from last meet. So how are we going to group these together? What shall we do? I would say this one and that one, yeah? So what can be factored out from that one and that one? A b squared, and then you're going to get a minus b. And then what can be factored out from these two? An a squared. No, let's factor out a negative a squared so that you get a minus b, see, which is the same as that. That's how factor by grouping works. You got to have a common factor here. And then when this one gets divided on this side, you get a squared minus b squared squared. Okay, so I factor out the a minus b. What's going to be left? B squared minus a squared. All over a squared minus b squared squared. What the heck, I'll just write it twice. Because then look, this over this is negative 1. And then this is a plus b times a minus b. And this cancels that. So all that's left is negative 1 over a plus b. So this is the x coordinate of the point of intersection. These are 2 lines. We're trying to find where they intersect. And I guess now's a good time to go over it since we're watching the video. In fact, this is a good way to test you when I see you in the hallway. If you have a system of equations and they intersect at one point, what do we call the system? Consistent. What if they're parallel and they don't intersect at all? Inconsistent. And what happens if the 2 lines are the same line? So they intersect at an infinite number of points. Dependent. Be ready to be tested when I see you in the hallway. Okay, let's skip to event 5. Now, this is the first time for this event, because this is the 50th anniversary of the Math League. Okay, so I believe the problem was, you start with the data 2, 3, 5, 8. If the number 12 is added to the set, how much does the variance increase by? Okay, well, how do you compute variance? Well, there's 2 things you got to know, variance and standard deviation. To compute variance, first you got to compute the average. Now, how do you compute the average of 4 things? We call that x bar. You add them up and divide by 4. So what is that? 2 plus 3 plus 5. 18 over 4 is 9 halves. So to compute variance, you have to compute the average first. What the heck, let's just do this one. So x bar for this one is, what is that? 30 over 5, which is 6. So to compute variance, you got to compute the squares of the deviation from the mean. So what you got to do is take the mean and subtract each of these elements from it. So this is 4 halves. 4 halves minus that is negative 5 halves squared. 25 fourths. Okay? And then 6 halves minus that, negative 3 halves squared, 9 fourths. And we just keep doing that. 10 halves minus that, squared, 1 fourth. 16 halves minus that, 49 fourths. So this is the sum of the squared deviations from the mean. And then you have to divide that by, there's 4 things, 4. Okay? Now it says compute the variance. This is the variance right here. If you were to square root it, that would be called the standard deviation. So variance is simply the square of the standard deviation. Now, some of you were doing the sample variance, which means you would divide by n minus 1. Some of you were dividing by 3, but it didn't say to compute the sample standard deviation, or variance rather. It just says compute the variance, so that's what it is. You don't divide by 3, you divide by 4. Now some of you are wondering, what the heck is sample? Well, if this is the entire population, and then you compute the variance of it, there you go. But what if you have something that has so many things you can't sample it all? Like for example, the weights of 18 to 35-year-olds in the United States. There's just too many of them. So you take a sampling. So if you take a sampling, then when you compute the variance, you have to divide by n minus 1. See, that's the difference. So this is the variance of this population here. What about this one here? So here's the mean. So again, you got to do the squared deviations from the mean, right? So 2 minus 6 squared, 16. 3 minus 6 squared, 9. 5 minus 6 squared, 1. 8 minus 6 squared, 4. 12 minus 6 squared, 36, and then you got to divide by 5. That is the variance. And then, I forget the question. The question was something about one is how much bigger than the other. Well, duh, subtract them. I will leave the computation to you. Now, corrections need to be turned in to me, or the corrections on the tryout for your events. Okay? So I will leave it to you to do the corrections and show it to me. And I'm going to check you off. Okay, now we're going to do the other events. Let's start with event 1. Now, even if you're in JV, you should be watching this, because if you're in Algebra 2, a lot of these things come up too. Like number 1, complex numbers. Solve for z. Z squared plus z times z conjugate minus z conjugate is equal to 6 minus 15i. Quite a few people got this one right, because you guys know what to do. You guys are math team veterans here. Now, first of all, if z is a complex number, z is a plus bi, right? That's what a complex number looks like. Z conjugate is a minus bi. You guys know what conjugate is, I hope. And all you got to do is plug it into here. So, a plus bi squared. You just got to do some algebra. Plus a plus bi times a minus bi minus a minus bi is equal to 6 minus 15i. So, multiplying this out, you get a squared plus 2abi plus bi squared, but remember, I squared is negative 1, so minus b squared plus a squared minus b squared I squared, so that's plus b squared, minus a plus bi equals 6 minus 15i. Now, when you work with complex numbers, what do? You group the real and the imaginary part separately. So on the left side of the equation, the real parts are these, things that don't have I in them. And on the right side of the equation, that's the real part. So what you do is you equate the real parts. So notice all these cancel out. So what do you got? 2a squared minus a equals 6. You equate the real on the left with the real on the right. And then imaginary, same thing. The imaginary parts are this and that. So on the left side of the equation, the imaginary parts are, what is that? 2ab plus b equals negative 15. The imaginary part on the left got to equal to the imaginary part on the right. And then you just solve these equations. Now, can you see there's going to be two solutions? Because look at this. What a surprise. It's a quadratic equation. And how do you solve it? You make one side 0 and you factor it. So you got 2a and a. What do we got? 2 and 3 minus plus. So a equals either -3/2 or 2. And then how do you figure out what b is? You take each of these and plug it in there. You get two answers. And make sure you write your answer correctly. Huh? This is the, see, a is the real part. So the two answers are going to be -3/2 plus something I, and then 2 plus something I. How do you figure out what these somethings are? You plug it back into here to solve to figure out what b is. I'm going to leave that to you. Okay, let's do number 6 first, because number 4 is the toughest, typically the toughest event in the whole year. I'm going to save that for last. Okay, number 6. Okay, a x minus bx equals c. Now, there's two ways of doing this problem. Okay, one is you just grind out the computations. Okay, so matrix A is 4, 3, 7, 5. Matrix X, we don't know what it is, so we call it A, B, C, D. Minus B, where's B? 1, 2, 3, 3, times X, which we don't know, A, B, C, D, is equal to matrix C, which is 5, 3, 2, 1. All right, so what you do is you just carry out the multiplication. So like over here, remember how you multiply? You go across and you come down, 4a plus 3c. Okay, 4b plus 3d. I don't want to do it this way. 7a plus 5c. But it works. 7b plus 5d. 7b plus 5d. And then you subtract. I'm not going to do this one. You guys are going to do it. Do that. Equals 5, 3, 2, 1. And then what you do is you subtract these two matrices. You just subtract the corresponding elements. And you're going to get something over here equals 5, 3, 2, 1. And then when you get to this step, you just say this got to equal 5. This equals 3. This equals 2. This equals 1. And then you solve it. Takes time. However, we have a better way. You do matrix algebra. Okay, so the first thing you do is you solve for matrix X. So, but you got to remember in this event, this is really important, the commutative property of multiplication doesn't work. In general, A times B is not equal to B times A. That is super important. Super important. So like over here, notice that the X is on the right. If you factor out the X, you have to factor it out on the right, because it's on the right. Some of you factored it out on the left. That's a fatal error. You cannot switch the order. The commutative property doesn't work. That's super important. This is supposed to be C full. And then, how do you solve for X? Can I divide both sides by A minus B? No, because division is undefined in matrices. So what you need to do is you need to multiply both sides by A minus B inverse on the left. And why is that so important? Because the commutative property doesn't work. So if you multiply this on the left here, you have to multiply it on the left there. You can't go multiply on the left on one side and then on the right on the other. That would be a fatal error. And what happens when you multiply the inverse of a matrix times a matrix? You get I, the identity matrix. It acts like, it's not the number one, but it acts like the number one. And the identity times any matrix is the matrix itself. So if you took PCH, you would know all this anyway. So, to find X, all you gotta do is do this, which is a lot simpler than doing this computations, working with four equations and 4 variables. So, first thing you do is you compute A minus B, which is easy. Okay, well, let me look at my paper. What is A minus B? 4 minus 1 is 3. 3 minus 2 is 1. 7 minus 3 is 4. 5 minus 3 is 2. Inverse times C, which is 5, 3, 2, 1. Okay, now, how do you compute the inverse of a 2 by 2 matrix? Well, that's easy. You go 1 over the determinant of this. Now, how do you compute a determinant of a 2 by 2? You go this times this, minus that times that. 6 minus 4, 2. It's called the determinant. Okay? And then you switch these two, and you negate those two. That's how you find the inverse of a 2 by 2. It's in the notes. And then on this one is 5, 3, 2, 1. Now, if it's up to you. This 1/2 you can distribute in here, or you could distribute in there. But what I like to do is I like to multiply these two first and then put the 1/2 in, because then that way you don't have fractions, yeah? So I'm going to multiply these two first. So let's go up here. So 1/2 times, okay, so you got to go across and come down. 10 minus 2, 8. 6 minus 1, 5. Negative 20 plus 6 is negative 14. Negative 12 plus 3 is 9. Negative 9, yeah? So now, to multiply a matrix by a constant, you multiply each element by that constant, and there you go. Boom. That's your answer. And then finally, the last event, we're going to need the whole board. Okay, where is it? Okay, first of all, I made a mistake when Olga submitted the problem, but I changed it a little, and then I made a mistake, so the problem actually became harder than it was supposed to be. So I'm just going to do the original problem because nobody got it anyway. That was because it's too hard. Okay, so the first thing you do, here is the equation of a circle in standard form. You got to put it in, general form. You got to put it in standard form so you can figure out where the center and stuff is. So you got to complete the square. You got 1 point for completing the square at least. So you put the x's together, leave a space. Put the y's together, leave a space. Throw the number on the other side. What do I have to add there? 9. What do I add there? 4. So I got to add 13 here. So you got x minus 3 squared plus y plus 2 squared is equal to 1. So the center of this circle is at 3, negative 2, and the radius is 1. It helps to draw a picture in this event, you know. Okay? And then it says it contains the point, find the slope of a line that contains the point 6, negative 5, but it should have been 6, negative 3. See, because the radius of the circle is 1, so 6, what's going on here? 3, negative 2. Oh, that's right. So 6, negative 3 would be over here somewhere, yeah? 6, negative 3. See how the radius 1, so this is negative 3. So when you draw in the tangent line there, it's supposed to have been a horizontal line. But it wasn't, that's why it was hard. Anyway, we want to compute the slope of this line here that's tangent to the upper half of the circle. What is the slope of this line? Well, y equal mx plus b, but then we're going to put it in general form, mx minus y plus b equals 0. Now, why is that? That's because we're going to use the distance between a point and a line. Okay, well, you can use that. There's two things you can do in this problem. I'm going to go over both of them. Now, this is what you got to know. ax1 plus by1 plus c all over the square root of a squared plus b squared. This is how you find the distance between a point and a line. Everybody knows that. However, not many people know this. ax1 plus by1 plus c all over plus or minus the square root of a squared plus b squared. This is the directed distance from the line to the point. Okay? So for example, it's called a directed distance. That means it can be negative sometimes. So if this is a line and the point is above the line, see the distance from the line to the point, it's positive because the point is above the line. But if the point lies below the line, then the directed distance would be negative because the point is below the line. Okay? So, how do you use this formula? Well, you pretty much use it the same as that, except there's no absolute value. And this plus or minus, you give the denominator the sign of b. That's how this formula is used. So if it comes out to a positive number, that means the point was above the line. If it comes out to a negative number, that means the point is below the line. Okay? We're going to actually use it in this problem. The other formula I want to talk about is this. Like if you have two lines, how do you find this angle between two lines? Okay, let's say the slope of this one is m1 and this one is m2. Well, first of all, to compute this angle, you have to first measure the angle counterclockwise because that's the positive direction in math. And then you just go tangent theta equal m2 minus m1 all over 1 plus m2 m1. M1 is the slope of the initial side of the angle. M2 is the slope of the terminal side of the angle. And that's when you measure it counterclockwise. See, that's why these things are tough. Okay, so the slope of this is 0. Okay, so again, when you draw the radius to the point of tangency, it makes a right angle like this. So the distance from here to here is 1, right? So therefore, the distance from here to here also has to be 1 because that's the radius of the circle. So I'm going to show you the two ways of doing it, and then you're going to solve it. I know how to solve it. You got to solve it. Okay, so let's use the directed distance. Okay, so notice that this point is below this line over here, but you got to draw the picture accurately so you can see that. Yeah. So therefore, what is the directed distance from this line to this point? Is it 1? No, it's -1 because the point is below the line. So let's use the formula. So here's the point. This is the equation of the line. The directed distance from the line to the point got to be -1. So how does it work? This is A, B is -1, and that's the C, yeah? So A, x1, so 3m, plus B, y1, so -1 times -2, plus 2, plus C, all over plus or minus the square root of a squared plus b squared, so m squared plus 1. We want that to be -1. Now, what do you do with that plus or minus? You got to give the denominator the sign of b. This is b. b is -1, so you have to give the denominator a negative sign. It depends on the sign of b. Okay, now we got one equation, but it got two variables in it. We need to write another equation. Where can we get another equation that involves m and b? This is why I didn't do the problem that way. Well, let's see. You could use the distance formula there. Okay, you know what? I'm too tired to do this. I'm going to show you the way I did it. Okay? Anyway, this is a good demonstration of how to use this formula. The way I did it is, see, when you draw this picture, when you draw the two tangents in like this, doesn't this angle here have to equal this angle here? So I'm going to use that formula. So this angle has to equal this angle, and the angles have to be measured counterclockwise. Now we know the slope of this because we got 2 points. So how do you compute the slope? Y minus y, which is 1, over x minus x is -3. So the slope of this one is -1/3, and this one is 0. So why don't we call this theta and theta? So tangent theta, let's do this angle first, is remember, you got to measure it counterclockwise. This is m1, this is m2. The initial side is m1, the terminal side is m2. So tangent theta is equal to m2 minus m1 all over 1 plus m2 m1. Okay, and then this angle is also theta, so tan theta equal, okay, but now m2 is, m1 is the initial side, so that's m. We don't know what that slope is. This is m1 and m2, so plug it into the formula. m2 minus m1 all over 1 plus m2 m1. But since these are equal, these got to be equal. So all you have to do is go this equals this and solve for m. Okay, I'm going to leave the computation to you. It's quite easy. And then that's why this problem, or these kinds of problems, you need to draw a picture to see things. All right, when should corrections be due? I'll think about it and put it in the email. All right.